Here we're going to look at a pretty cool application of integrals. We're going to be finding the area between two curves. And we've looked at the properties of integrals already, so this kind of follows pretty easily from that. And so it says here, if f of x is greater than or equal to g of x over the interval a, b, then the area between the curves is found by the integral of f of x minus g of x dx from a to b. In other words, if f of x is higher than g of x on the graph. So we will look at a few different variations. The first variation tells us the boundaries of the interval are given and one function is above the other on the whole interval. So that's the first type. That's going to be a little bit simpler. So let's go ahead and look at this one. I kind of I have some of the work here, or the graph here at least. So first thing you want to do, is read the example. So find the area between y equals x squared plus 3 and y equals 1/2 x minus 1 on the interval from -1 to 2. It's often helpful to have a quick sketch of this graph. We're very familiar with both of these functions. We have a parabola that's just moved up 3 and a line. So very easy to graph, so you can sketch that graph. It doesn't have to be exact. It just gives you an idea, especially that the parabola is higher than the line. And so what we want to do here is we want to integrate from -1 to 2 of the higher function minus the lower function. Well, the higher function is the x squared plus 3, and then the lower function is the 1/2 x minus 1. So we're going to write that definite integral. So here it is, integral from -1 to 2 of the higher minus the lower. And then we can find that integral. We could simplify this first by distributing the negative and adding any like terms. And then we'll go forward with it and solve. So here it is. We added like terms. Well, we distributed the negative and added like terms. And then we can integrate. That's what this step is here. We took the integral. Now we'll plug in our values for the upper and lower bounds, the limits of integration, and we simplify. And so the work is shown there. We end up getting 57/4, and we would say units squared. So that is our answer. Again, the concept is fairly simple. You integrate. You use the left bound and the right bound for your limits of integration, and the higher function minus the lower function. This next one, example 2, find the area between f of x equals sine x plus 1 and g of x equals cosine x minus 1 from 0 to pi. We could sketch each of these. So in orange here, we will graph sine of x plus 1. So the whole graph is moved up 1. So instead of going through the x-axis, it will be up 1. At pi over 2, it gets up to 1, back down to 0. And I say 0, but the midline, the whole thing is shifted up. So there is a quick sketch of y equals sine of x plus 1. And then in green, we'll go ahead and graph cosine of x minus 1. So it's going to be the cosine graph, but moved down 1, which means like this would be the midline of the cosine one. So it starts at 0 because it's moved down 1. Goes down to the midline, goes down below the midline, and back up. And really, we don't need much of this because it's just asking for between 0 and pi. So let's go ahead and show that area. So that's in here from 0 to pi. Now, we didn't need that graph. It's helpful to draw the graph. That's one of the first things it's helpful to do. And then we can write our definite integral. We were given the two limits of integration here, and so let's see, let's write our integral. So this will be the integral from 0 to pi of the higher one, which was sine of x plus 1, minus the lower one, which was cosine of x minus 1 dx. We can distribute, so we'll simplify and solve. So 0 to pi, first we'll simplify, so sine of x plus 1 minus, distribute that negative, so minus cosine of x plus 1 dx. And we'll simplify a bit further. Well, actually, yeah, we will. So we've got sine of x minus cosine of x plus 2. We'll go ahead and integrate now. So the integral of sine is negative cosine. Integral of cosine is just sine, so minus sine of x plus 2x. Evaluated from 0 to pi. So we'll plug in pi, so negative cosine of pi minus sine of pi plus 2 times pi. We're going to take that whole thing and subtract when we plug in 0. So negative cosine of 0 minus sine of 0 plus 2 times 0. And now it's just a matter of simplifying that. Cosine of pi is negative 1. So we're looking at this. So negative 1, so that's 1. Minus sine of pi is 0, so minus 0 plus 2 pi. And then we're going to subtract. Cosine of 0 is 1, so that's negative 1. Sine of 0 is 0, and obviously 2 times 0 is 0. Which gives us 1 plus 2 pi plus 1. So the answer is 2 plus 2 pi units squared. So that's the first part of this lesson. That's when we just have one graph is always above the other graph in the interval that we're referring to.